This will be a brief video highlighting normality. Returning to the concentration problems, just looking at the last three, we'll start with number 10. What is the normality of a solution containing 2.56 grams of barium hydroxide in 135 milliliters of solution? Normality is the equivalence per liter of solution. So I'll just start with my 2.56 grams of barium hydroxide. Well, I know that equivalents are related to moles. Barium hydroxide, every 1 mole, has 2 equivalents. Remember, equivalent for a base is the amount that can neutralize, per mole, that can neutralize 1 mole of hydrogen ion. Well, for every 1 mole of hydrogen ion, I have 2 moles of hydroxide available. So what I need to do is get to moles. And for barium hydroxide, 171.35 grams are in every 1 mole. And for every 1 mole, per our formula, there are 2 equivalents. And normality are equivalents per liter of solution. I'm given 135 mils. I can make that transition in my head. And so what I'll end up doing is canceling everything but equivalent per liter. And this will not restrict, it's an exact value. We get 0.221, and equivalent per liter is normal. And what is our solute? Barium hydroxide. Nice and easy, nice and easy. Our second problem, what would be the mass of sodium hydroxide found in 250 milliliters of 2.5 normal sodium hydroxide solution? All right, I'm going to start out with my simpler expression, and that would be just my volume versus a combined or something that I can expand out, my concentration expression. For every 250 milliliters of solution, there's 1,000 mils per liter of solution. And per my normality, for every 1 liter of solution, and going with 2 sig figs to respect that, there are 2.5 equivalents. Well, there's 1 equivalent in every 1 mole of sodium hydroxide. So I'm letting the problem guide me. Here, I've canceled liters to get to equivalents. So equivalents will go here into moles. And for every 1 mole of sodium hydroxide, it's 40.01 grams. And that gives me 25 grams of sodium hydroxide for my answer. So the key is knowing when and how to use the relationship of equivalence and normality. For number 9, that deals with just an expanded demand of mole fraction. So those are the extent of the normality type of problems. So for number 9, an aqueous solution of magnesium hydroxide has a mole fraction of water. All right? And that would mean that's moles of water over mole of water plus mole of my solute, which is magnesium chloride here. Okay. What is the mass of the solute per 500 grams of solvent? What is the mass of the solute? So, I wonder if I could somehow get this. I know I have 500 grams of my solvent, which is water here. I know that it's a smaller mole fraction. However, water, compared to an ionic compound, we know that water will be our solvent. If I can get myself to 2 grams, to moles, and here 27.7 moles of water per the 500 grams. Oh, and then look. inputting what I've just solved for. And then I can just find my moles of magnesium and then rearrange the equation. I would treat this as, you know, an entire expression, bring this up, multiply through, and then what we end up getting, 0.3 times our 27.7 is 8.31, and that would technically be moles of water, plus 0.300 moles of magnesium chloride, yeah, equals the 27.7 moles of water. Then subtracting over, we would get the 0.300, you know, in terms of times the mole of magnesium chloride. So in essence, this is my x, yeah, my x. So that's why this is like, you know, a coefficient to this variable. This is what I'm trying to solve for. Subtracting that over, let's see. Having trouble following my work. What we're going to end up... so subtracting that over, then dividing out by 0.3, there we go. Then our x, or our mole of magnesium chloride. So, and what we're going to get about 18 something here, or something something. And then dividing that by the 0.300. Okay, then we end up getting 11.1. And then converting 11.1 moles of magnesium chloride to grams. And we get, with 6 eggs, 1,060 grams of magnesium chloride. So that was just seeing with what we were given, and then just being careful of how we would set things up and solving, we'll get that answer. So this should get you ready for the combined style of problems that we will see in the next lesson.